Okay, so continuing from the last video, welcome back to the third lecture in the series, Introduction to AI. In this video, we are going to discuss about rational agents and how an agent can be called rational under different circumstances. Or as we are going to take a look in this video, the task environments, which are essentially the problems to which rational agents are the solutions. In the last video, we discussed about rationality by explaining a simple example of a vacuum cleaner agent, and we had to specify the environment and the agent's actuators and sensors. We grouped all these under the term we call task environment. We also call this the P's description. In designing an agent, the first step must always be to specify the task environment as fully as possible. So let's take a look at what these are with the help of advanced example. We are going to be using an example of automated driving car, or as we nowadays call them, autonomous vehicles. The full driving task is extremely open-ended. There is no limit to the novel combinations of circumstances that can arise. So if you take a look at the tables shown, we can understand the parameters of performance, environment, actuators, and sensors a little more clearly. So what is a performance measure? It's a sort of set of desirable qualities of an agent. In this case, it should be safe, fast, legal, should get to correct destination, minimizing fuel consumption and wear and tear, minimizing the trip time or cost, minimizing violations of traffic laws and disturbances to other drivers, and so on. Next, we have environment, meaning what is the driver environment that the car will face. It should be aware of such environments like highway roads, simple roads, traffic, pedestrians, 12-lane freeways, roadworks, police cars, puddles, and so on. And so we can sort of get an idea that an agent has these environments known to it. Then we have the actuators. An actuator is basically the ability of changing something in itself. An agent uses actuators to perform tasks. Examples of actuators can be an accelerator, brake, and other car functions. Such controls are known as actuator. So in our case, the autonomous car's program is the agent, and all functions of the car are its actuators. Then we have the sensors. The sensors for the car will include one or more controllable video cameras so that it can see and read. It might augment these with infrared or sonar sensors to detect distances or other cars and obstacles. And to avoid speeding tickets, the car should have speedometer. And to control the vehicle properly, especially on curves, it should have an accelerometer and electrical system sensors. So while making an agent, we have to take in account all this information about the P's description, because failing to do so will result in an agent itself that is not rational. And so this is definitely something to read about while making an artificial intelligence. And once again, we are just discussing the structure of AI using some of the terminology that the scientists have derived themselves to not only understand the nature of rationality, but also to construct rationality in computers as well. So let's now discuss a little bit about the properties or categories of task environments, which may really just depend on the way problem is designed that we are trying to solve using agents. So first we have the visibility of environment, either fully observable or partially observable. If an agent's sensors give it access to the complete state of the environment at each point in time, then we can say that the task environment is fully observable. An environment might be partially observable because of noisy and inaccurate sensors, or because parts of the state are simply missing from the sensor data. For example, a vacuum agent with only a local dirt sensor cannot tell whether there is dirt on other squares. And self-driving cars cannot completely sense other drivers' decisions. Next up, we have deterministic and stochastic properties. If the next state of the environment is completely determined by the current state and the action executed by the agent, then we say that the environment is deterministic. Otherwise, it's stochastic. In principle, an agent need not worry about uncertainty in a fully observable deterministic environment. If the environment is partially observable, however, then it could appear to be stochastic. Most real situations are so complex that it is impossible to keep track of all unobserved aspects. For practical purposes, they must be treated as stochastic. Autonomous car is clearly stochastic in this case, because one can never predict the behavior of traffic exactly. In an episodic task environment, the agent's experience is divided into atomic episodes. In each episode, the agent receives a percept and then performs a single action. Crucially, the next episode does not depend on the actions taken in previous episodes. Many classification tasks are episodic. For example, an agent that has to spot defective parts on an assembly line bases each decision on the current part, regardless of the previous decision. In sequential environments, on the other hand, the current decisions could affect all the future decisions. If the environment can charge while an agent is deliberating, then we say the environment is dynamic for that agent. Otherwise, it is static. Static environments are easy to deal with because the agent does need to keep looking at the environment while it is deciding on an action. So we sort of use all these things in making a successful intelligent agent. In the next video, we will take a look at agent structures and agent program types. Once we have established a study of base structure of these agents, we can move on to the actual part where we design the agent to solve problems. And there will be study about mathematical ways that are used as a base for computer problem solving.